Hello all, in this video we are going to talk about force update in mobile app. This feature is a non-functional requirement and can sometimes act as a double-edged sword. Let's deep dive into the concept and try to understand what it means to build a force update in a mobile app. This video classifies force update as a non-functional requirement. On the contrary, some would like to classify it to be a app feature instead. Irrespective of what the classification is, the underlying concept and the implementation remains the same. Let's try to understand what force update is all about. In a mobile application, it is a means to indicate to the end user the availability of a later version. And in the point of an enterprise, force update would be a means to ensure security fixes, bug fixes, compatibility, etc. are reaching to the end user. This would in turn help to retain the credibility with the end consumer. Now, let's look at the implementation. The basic fundamental idea is that there are two versions, one which is the actual app version compared with the remote version, which is configured. In the approach one depicted, the config fetch happens and the comparison is implemented on the mobile client. The validation logic to validate and verify if the force update pop-up needs to be shown or not happens on a mobile application. Whereas, on the contrary, the approach 2 sends the app version to the backend to validate and send the response back and appropriately handle displaying of the pop-up. Implementing force update is a double-edged sword. We are actually interrupting or in some cases denying the services to the end user due to the criticality and the nature of force update. This can attract negative reviews of the application on the App Store. Therefore, communicating the intent and telling the importance of this would be best practice to reduce the negative reviews. Now, let's look into the force update modes. There are three modes in which force update operate. Let's look into each of these in detail, starting with mandatory force update. If you look at this slide, the pop-up that states app version is no longer supported, please update to the new version of app is a blocking pop-up. A code base checks if the current version of the app is at least the minimum supported version, and based on that logic, it displays the pop-up. Once this pop-up is shown, the user will not be able to use the application. The individual will have to quit the application or update the application in order to use it. The next mode is an optional force update. This, unlike the mandatory force update, does not block the user. The app version is still above the minimum supported version, but it is not the latest version. Therefore, the pop-up would give an indication to the end user that a new version of app is available and the individual can skip or choose to update to the latest version. The third mode, siloed force update, uses the force update capability to indicate the user that a particular feature within the application is unavailable. In order to use or you know use alternative solution, the end user may have to update the application. This is equivalent to optional force update with the caveat that optional force update is shown for the entire app, whereas siloed force update would be for a particular feature. If the user never uses that feature, the individual may never see this pop-up. Now that we have looked into enough theory, let's try to create a mind map by looking into the force update situations. The slide shows remote config rules. It states that the minimum version supported is 1.5.1 and the latest version is 2.1.0. Any version of the app that is less than 1.5.1 will not be supported. Now, let's look at the table. The installed app version is 2.1.0. This is equivalent to the latest version. Therefore, there is no need of force update to be shown and the application behaves as usual. Second is 1.5.0. This is less than the minimum supported version. Therefore, it will be mandatory force update. The last one, 2.0.0, is in between the minimum supported version and the latest version. Therefore, the optional update is ideal and it will be shown when the user opens the application. Additionally, before moving to the next, wanted to reiterate the fact that latest application shall not show force update pop-up. Now, let's look into some of the key consideration during implementation. The network core are bound for failure. Therefore, having a fallback mechanism where caching the previous config would help to you know do a app version check and take an appropriate logic. There are different thought processes, but the idea is that there should be a fallback mechanism in case of a network failure. Maintaining versions of config. Now, the manual effort to maintain configurations in the server is an overhead. And in an organization where there is a multiple OS, such as Android, iOS, etc., coordinating with these would be an overhead. There should be a thought to handle these at an operational level. In any mobile application, the login and post login screens will be there. There could be applications where an app can be used without login. Now, in this case, depending on the context, where to implement force update check is a design consideration that the team must think about. Another consideration is to have a check on every service call. This might be due to any compliance requirement where app version would be sent as part of every service call, and if it doesn't meet the compliance requirement, the response would be given to the mobile to show a force update. The decision to add on every downstream system call may not be intuitive. However, the criticality of the application would dictate, and this would become an essential aspect in the application due to the compliance requirement. Retaining the context. Now, after force update, let's say the user updates the application, but the application is throwing out the user from the context that he was operating. That is not a great user experience. Having the data migrated gracefully, and if we are allowing the user to restart from the point where the individual has left, it would be a great user experience. Having this thought in the implementation consideration would be ideal. Denial of service and interrupting the user is an anti-pattern. Therefore, it should be ensured that how many times the force update pop-up is shown to the end user and what is the instance where the pop-up would be triggered should be carefully designed to reduce the intimidation. Now, let's look at a quick demo. The key idea conveyed in the demo is how force update logic is implemented. It is a simple application and we will not be connecting to a backend service. It will be mocked. The export project of the application is open. Let's try to run the application. The application has the current version and a button. On click of the button, the version would be checked and appropriate pop-up would be displayed. The presentation layer has the content view and the pop-up card view that would be displayed. Now let's look into the service. It is a hard-coded implementation where we respond with some pre-populated values. This is actually for demo in order to maintain the simplicity and avoid any network calls. In ideal case, this would be an actual network call that returns a value, which is similar. Let's go into force update resolver. The three modes are defined, mandatory, optional, and no update. However, we have not added siloed mode because we are not going to show that in this demo, but it will be similar to the current implementation. The force update resolver takes in the version service protocol as constructor parameter. This is actually in order to differentiate test versus actual implementation. In this case, there is a method called check force update, which has signature of a string, and that is the app version. The app version is now compared with the response returned by the version service. And if the app version is less than the minimum mandatory version, the mode is returned as mandatory. Now, minimum mandatory version is not a must have field in the response. If you see, config one doesn't have mandatory version, right? If the backend or the response from the server doesn't have mandatory version, that means that only latest version needs to be checked. And if the current app version is less than the latest, only the optional force update pop-up will be shown. Whereas if there is mandatory, it would also check for mandatory force update mode as well. Now let's go into the test. The test case written covers the validation of check force update function. There are two tests, one with mandatory parameter nil from the response and other with the mandatory parameter. The test case has a array which has app version, which is input versus the expected result. The only difference that you could see is that in case of the test where mandatory parameter is null, the expected output is always optional. Whereas in the other case, it is having a mandatory. Thus, after running the test, all our assertions are true and thereby validates our logic. Now, let's try running the application and trying to update the app version in the project. We'll try with the version that is less than the minimum mandate version. And if you see in the application, it's the blocker pop-up. Let's stop the application and try to change it to a higher version than the minimum required version. In this case, the optional pop-up for force update will be presented. Now, let's run the application once again. We are getting the update action also. In actuality, this will be redirected to App Store. Let's try to give the same version as the latest version. In this case, in the check app version, nothing happens. The button click is actually for the demo. In reality, it will be implemented to show the force update pop-up without user interaction. Let's try to change the config without the mandatory response. And let's try to add a version that was less than the previous minimum version. In this case, since the minimum is not coming in the response, it will be always the optional force update mode that will be activated as depicted in the simulator. Thus, let's wind up looking into some of the key highlights. Force updates are crucial for conveying security issues, bug fixes, or even the app quality. Team should balance the need for update with respect to user experience. Communicating effectively and providing accurate information will mitigate any resistance from end user. Force update checks the app version with a remote version to give indication to the user for later version. With that, we have reached the end. Thank you for watching and hope to see you apply the takeaway and learning.